NEC 110.10 mandates that electrical equipment must withstand the available fault current at its connection point, and this includes refrigeration equipment. The refrigeration equipment manufacturer is responsible for ensuring their products comply with safety standards, including NEC 110.10. If the manufacturer doesn't provide a fault current rating, they must determine and specify necessary protection measures. The authority having jurisdiction, or OJ, is correct in applying NEC 110.10 to refrigeration equipment. However, assuming a 5 kA interrupting capacity or 5 KIC rating for refrigeration equipment without supporting evidence isn't justified. A calculated fault current of 22 KIC at the equipment termination point is a valid assessment. The AHA should accept this value unless they have specific evidence supporting a different fault current. Properly rated main and feeder overcurrent devices meet NEC 110.10 requirements, providing adequate fault current protection for the refrigeration equipment. The AHA interpretation could impact other equipment like elevators and heating, ventilation, and air conditioning or HVAC systems, emphasizing that NEC 110.10 applies to all electrical utilization equipment. To summarize, the AHA interpretation of NEC 110.10 is correct, but assuming a 5 KIC rating without evidence is not justified. The 22 KIC calculated fault current is valid, and appropriately rated overcurrent devices provide sufficient protection. Therefore, the refrigeration equipment meets NEC 110.10 requirements. The AHA should revise their interpretation accordingly. Now let's delve deeper into the specifics of NEC 110.10 and its implications for refrigeration equipment. First, let's clarify what we mean by available fault current. This is the maximum amount of current that a circuit can deliver under short-circuit conditions. It's determined by the characteristics of the electrical system upstream of the equipment, including the utility transformer, conductors, and other components. The calculated fault current of 22 KIC indicates that, at the point where the refrigeration equipment connects to the electrical system, the system is capable of delivering up to 22,000 amps of current in the event of a short circuit. This is a significant amount of current, and it's essential to ensure that all equipment connected to the system is capable of withstanding it. Secondly, let's discuss the manufacturer's responsibility in more detail. UL listing, while important, does not always guarantee compliance with NEC 110.10. UL standards primarily focus on product safety under normal operating conditions, not necessarily under fault conditions. Therefore, it's the manufacturer's responsibility to determine whether their equipment can withstand the available fault current at its point of connection, or to specify additional protection measures that are necessary to ensure safety. These protection measures could include, for example, the use of current-limiting fuses or circuit breakers. Thirdly, let's examine the AHA role in enforcing NEC 110.10. The AHA is responsible for ensuring that all electrical installations comply with the NEC and other applicable codes and standards. This includes verifying that equipment is properly rated for the available fault current at its point of connection. However, the AHA enforcement must be based on sound engineering principles and available evidence. In this case, the AHA assumption of a 5 KIC rating for the refrigeration equipment without any supporting evidence is not justified. The AHA should accept the calculated fault current of 22 KIC unless they can provide specific evidence to support a different value. Fourth, let's consider the implications of NEC 110.10 for other types of equipment in the building. As mentioned earlier, NEC 110.10 applies to all electrical utilization equipment, regardless of its specific application or function. This means that equipment such as elevators, HVAC systems, and other appliances must also be able to withstand the available fault current at their point of connection. However, the level of protection required may vary depending on the specific equipment and its application. For example, equipment that is critical to life safety, such as fire pumps or emergency lighting, may require a higher level of protection than equipment that is not. Fifth, let's discuss the different types of overcurrent protection devices that can be used to protect equipment from fault currents. Overcurrent protection devices, such as fuses and circuit breakers, are designed to interrupt the flow of current in the circuit when the current exceeds a certain level. These devices are typically rated in terms of their interrupting capacity, which is the maximum amount of current that they can safely interrupt. When selecting overcurrent protection devices, it's essential to ensure that their interrupting capacity is equal to or greater than the available fault current at the point of installation. Furthermore, the overcurrent protection devices must be properly coordinated to ensure that they trip in the correct sequence in the event of a fault. Finally, let's address the issue of series ratings. Series ratings allow the use of overcurrent protection devices with lower interrupting capacities if they are installed in series with other overcurrent protection devices with higher interrupting capacities. However, series ratings must be carefully evaluated to ensure that they provide adequate protection for the equipment. In this case, the AHA has stated that they cannot prove a series rating to 22 KIC with any overcurrent protection, whether fused or malted case circuit breaker. If this is the case, the AHA believes the refrigeration equipment must be fully rated. The main and feeder overcurrent devices are fully rated for the calculated fault current, which meets the requirements of NEC 110.10. Therefore, the refrigeration equipment is adequately protected from fault currents. In conclusion, NEC 110.10 is a critical safety requirement that must be carefully considered when designing and installing electrical systems. By understanding the requirements of NEC 110.10 and working closely with manufacturers and AHA, it's possible to ensure that all equipment is properly protected from fault currents. Let's elaborate further on the crucial aspects of fault current, overcurrent protection, and the application of NEC 110.10, particularly concerning refrigeration equipment and the responsibilities of various parties involved. Firstly, understanding fault current calculations is paramount. The 22 KIC calculated at the termination point of the refrigeration equipment represents the prospective fault current. This calculation typically involves considering the utility's available fault current at the service entrance, the impedance of the service conductors, transformers, any intervening overcurrent protective devices, and the feeder conductors leading to the refrigeration equipment. Accurate fault current calculations are essential for selecting appropriately rated equipment and overcurrent protection devices. Secondly, overcurrent protective device selection is critical. Overcurrent protective devices, such as circuit breakers and fuses, are designed to protect equipment and conductors from overloads and short circuits. These devices have two primary ratings that are relevant in this context: the ampere rating and the interrupting rating. The ampere rating indicates the amount of continuous current the device can carry without tripping, while the interrupting rating, expressed in kiloamps, indicates the maximum fault current the device can safely interrupt without failing. In the situation described, the overcurrent protective devices must have an interrupting rating equal to or greater than the calculated fault current of 22 KIC at their point of installation. This ensures that the devices can safely interrupt the fault current in the event of a short circuit, preventing damage to equipment and reducing the risk of fire or electrical shock. Thirdly, UL listing and fault current ratings are important. While UL listing indicates that a product has been tested and certified to meet certain safety standards, it does not necessarily guarantee that the product is suitable for all applications. In the case of refrigeration equipment, the UL listing requirements may not include withstand rating testing for fault current. This means that the equipment manufacturer may not have tested the equipment to determine its ability to withstand high fault currents. However, as per NEC 110.10, the equipment must still be able to withstand the available fault current at its point of connection. Therefore, it is the manufacturer's responsibility to provide information on the equipment's fault current withstand rating or to specify additional protection measures that are necessary to ensure safety. Fourthly, the AHA role and interpretation needs clarification. The AHA plays a crucial role in enforcing the NEC and ensuring that electrical installations are safe and compliant. However, the AHA interpretation of the code must be reasonable and based on sound engineering principles. In this case, the AHA assumption of a 5 KIC rating for the refrigeration equipment without any supporting evidence is questionable. The AHA should accept the calculated fault current of 22 kIC unless they can provide specific evidence to support a different value. Furthermore, the AHA should work with the equipment manufacturer and the electrical contractor to determine the appropriate level of protection for the refrigeration equipment. Fifthly, series ratings and coordination should be understood. Series ratings allow the use of overcurrent protective devices with lower interrupting ratings in series with other overcurrent protective devices with higher interrupting ratings. This can be a cost-effective way to meet the fault current requirements of the NEC, but it is important to carefully evaluate the series rating to ensure that it provides adequate protection for the equipment. The series rating must be verified by the manufacturer of the overcurrent protective devices and must be based on testing that demonstrates the devices will coordinate properly under fault conditions. In the situation described, the AHA has stated that they cannot prove a series rating to 22 kIC with any overcurrent protection. If this is the case, the refrigeration equipment may need to be fully rated for the available fault current. Sixthly, practical implications for other equipment must be considered. The AHA interpretation of NEC 110.10 could have significant implications for other types of equipment in the building, such as elevators, HVAC systems, and other appliances. All electrical utilization equipment must be able to withstand the available fault current at its point of connection. This means that the electrical contractor and the equipment manufacturer must carefully evaluate the fault current withstand ratings of all equipment and select appropriately rated overcurrent protective devices. In some cases, it may be necessary to install additional overcurrent protection devices or to upgrade the electrical service to increase the available fault current. Finally, documentation and communication are key. It is important to maintain clear and accurate documentation of all fault current calculations, equipment ratings, and overcurrent protective device selections. This documentation should be readily available to the AHA and other interested parties. Effective communication between the electrical contractor, the equipment manufacturer, and the AHA is also essential for ensuring that the electrical installation is safe and compliant. In conclusion, NEC 110.10 is a critical safety requirement that must be carefully considered when designing and installing electrical systems. By understanding the requirements of NEC 110.10, the responsibilities of various parties involved, and the practical implications for other equipment, it is possible to ensure that all equipment is properly protected from fault currents. Let's expand on the discussion to provide even more clarity on the subject matter. Firstly, NEC 110.10 states that equipment intended to interrupt current at fault level shall have an interrupting rating sufficient for the nominal circuit voltage and the current that is available at the line terminals of the equipment. This means that any equipment designed to interrupt fault current, such as circuit breakers and fuses, must have an interrupting rating that is equal to or greater than the available fault current at its point of installation. The NEC also states that equipment intended to be protected from fault current shall have a short circuit current rating not less than the available fault current at its supply terminals. This means that any equipment that is not designed to interrupt fault current, such as panel boards, switchboards, and motor control centers, must have a short circuit current rating that is equal to or greater than the available fault current at its supply terminals. Secondly, the available fault current at a particular point in an electrical system is determined by the impedance of the system upstream of that point. Impedance is the opposition to the flow of alternating current and is measured in ohms. The lower the impedance, the higher the available fault current. The impedance of an electrical system is affected by a number of factors, including the size and length of conductors, the number and size of transformers, and the presence of any reactors or other impedance-limiting devices. Thirdly, fault current calculations are typically performed using a point-to-point method, in which the available fault current is calculated at each point in the system, starting at the source of power and working downstream to the equipment. The point-to-point method takes into account the impedance of all of the components in the system, including conductors, transformers, and overcurrent protective devices. Fourthly, overcurrent protective devices are designed to protect equipment and conductors from overload and short circuits. Overloads are currents that are higher than the normal operating current of a circuit but are not high enough to cause a short circuit. Short circuits are currents that are much higher than the normal operating current of a circuit and are caused by a direct connection between two or more conductors. Fifthly, the interrupting rating of an overcurrent protective device is the maximum fault current that the device can safely interrupt without failing. The interrupting rating is typically expressed in kiloamps. It is important to select overcurrent protective devices with interrupting ratings that are equal to or greater than the available fault current at the point of installation. Sixthly, the short circuit current rating of equipment is the maximum fault current that the equipment can withstand without being damaged. The short circuit current rating is typically expressed in kiloamps. It is important to select equipment with short circuit current ratings that are equal to or greater than the available fault current at its supply terminals. Seventhly, series ratings are allowed by the NEC under certain conditions. A series rating is a combination of two or more overcurrent protective devices that are installed in series and have a combined interrupting rating that is higher than the interrupting rating of the individual devices. Series ratings must be carefully evaluated to ensure that they provide adequate protection for the equipment. Eighthly, coordination is the process of selecting and setting overcurrent protective devices so that they trip in the correct sequence in the event of a fault. Coordination is important to minimize the extent of the outage and to prevent damage to equipment. Ninthly, documentation is essential for demonstrating compliance with NEC 110.10. Documentation should include fault current calculations, equipment ratings, and overcurrent protective device selections. The documentation should be readily available to the AHJ and other interested parties. Finally, communication is key to ensuring that electrical installations are safe and compliant. Effective communication between the electrical contractor, the equipment manufacturer, and the AHJ is essential for resolving any questions or concerns that may arise. By following these guidelines, it is possible to ensure that electrical systems are designed and installed in accordance with NEC 110.10 and that equipment is properly protected from fault currents.